the opportunities for kids there are here. We want to hook kids in. We want to get them interested in math. We want to get them interested in science. We want to get them interested in design. And we tell them, hey, listen, if you work hard and you get a good enough model, somebody in here could possibly have the ability to sell their product. That's fantastic. You know, it's not, when we talk about real world, nothing gets more real world than bringing it down to consumerism. I mean, we all live in a capitalist society. We know how that works. They're online. They see all this stuff. They would love to sell their stuff. And this is an opportunity. There we go. So have all types of design options, all types of things. And some of it is literally just a 3D model. They don't even make a product. They never print it out. They just do a design. And then if enough people fund it and like it, there's a toothbrush with toothpaste attached to the top. Something easily a kid could have 3D designed. Maybe it was designed by a kid. All right, take a look. So we talked about the why. I think there's a good idea, but how about the how? Well, 3D scanning has actually been around for a long time. It's not a new thing. But the technology to accomplish it has been fairly expensive. There's three main ways of doing it, but the process is pretty straightforward. You need to develop something called a point cloud, which is a series of points in space that mark the surface of your object. Now, if I was going to connect 2 points in space with a straight line, right, we could all picture that, right? 3 points in space, give me a plane, right? And you can see as I add more points, I can start to get my three-dimensional objects. 4 points in space, we can get a space. The more points I add, the more texture I can get. So the goal is to get as many points as you possibly can to get a good texture and a good 3D design. Then all those points are connected into surfaces. So it creates a 3D mesh. So with those points, do all the geometry and connect it, and you get a 3D mesh. More points, better mesh. Finally, you have to smooth it out. You take that mesh, all the rough edges, and you smooth it out. Last piece, other than being a gray blob, you want to paint it. And you want to paint it with some type of texture. Now that might be a texture that you would import it. It might be a texture of the original object. And that's the basic idea. Here's an example. This is Monmouth Castle in southeast Wales. And you can see this is a point cloud. That's what a mesh looks like from that point cloud. We take something and we smooth it out. And now it looks like a clay model. And then finally, that clay model adds a surface. So this is what, if we took a graphic of somebody's clothing and cut it out and laid it flat, that's what it would look like. Or if you imagine, if you take the globe and you open it out, sometimes it's easier for us to see, and you have that shape, that is the globe. That's a surface that you can attach to a 3D object. Now this all sounds really complicated. Right? This sounds like there's a lot of work involved to make this happen, but it's actually not as complicated because the modern software and technology that we have allows us to do it. The three main methods. Laser was the original. This was the way that it was originally described and designed. There's lots of do-it-yourself projects that you can find on how to use lasers to do this. You essentially take a laser and a camera, and you run the laser over the object with the camera, and the software picks up the points where the laser touches the object and distorts, and it will give you your point cloud. So all the real work is in the software. Not very expensive to set up, however, does take a bit of sophisticated know-how. You know, you have to get a laser somewhere, you have to set it up, you have to get the table to get it to rotate. You have to have the camera set up, right? But the software in most cases is free. Does require a little bit of know-how to get set up and running. I typically don't go too much into the laser software because there's so much do-it-yourself information out there, and it's kind of up here for most people. But if you're running an engineering class, designing the laser scanner with them is absolutely a great project. However, there's two other ways of doing it. The first one is called, and I always screw up the way you pronounce this, it's photogrammetry. I think I got that right. Photogrammetry. And I really like this method because it's very accessible. It essentially consists of taking a whole bunch of pictures. Take a bunch of pictures, you move around your object, get lots of good views of it, and then you crunch it into some software, and the software spits out your mesh, well, your point cloud, then your mesh, and attaches the images and gives you your 3D surface layer. Really nice. Takes a lot of computing power. It can take a long, long time for the computer to analyze all of those images and get that put together into your picture to get your 3D model. The last version is the Kinect. I'm going to demonstrate that here today. But this is the original Kinect. You can get them on eBay for like $15 at this point. They have the new one, the Microsoft One Kinect, which is a little bit better because it works natively with some Microsoft objects, Microsoft apps that are built in, and then connects right to a 3D printer. So you got to go up to about $50 if you want to get that one. So for about $15 investment, this is a pretty good tool. And we'll demonstrate that.
What was the other one?
Well, the other one, the Microsoft One.
Okay.
Xbox One, yeah.
Okay.
So some pieces of hardware that you would need to do each of these. First, the laser. If you were going to do the laser method, you would need a laser line level, you need a computer with a webcam, and you need a foam board because you got to build a box. Put this in. Once you do that, the software that you would need is David laser scanner software. And all these resources are up on the link, so you can just click on the link and you'll have this PowerPoint. And these are all hyperlinks, so you can click right to it. And then you need Blender. How many people have ever worked in Blender? Okay. Oh, I hear the yeah. Okay, so when you open Blender, if you've ever opened up Blender, it looks like you could build the Eiffel Tower if you had about 3 years to figure out all of the controls. Now, I love gadgets and I love figuring that stuff out, but then I look at it and go, wow, I don't know if I could teach that in a marking period. You know, so the learning curve on Blender is fairly high. At a tech school, absolutely, they should be using Blender and they should be doing modeling and design, and that should be part of their curriculum throughout that tech program track. But maybe if you're trying to do this in your classroom as a couple-day lesson for a one-off or something like that, you're not going to want to hit this. This is just going to be way too much overkill for you to use. Essentially, you print out a sheet of dots. The laser gets scanned over, and where the dots get blocked out and where the laser crosses the object, the software does all the work for you. There's a link to exactly how to build it. It's by some guy called Tinkernut. And he has the designs and he has demonstrations and all the software for it. So if you really want to tackle this, that's where you go. This one's a little bit more fun. Photogrammetry. And we're going to try this. You can open up the app and I'll take you a look, let you take a look. But you do need some space to make this happen. And there's a couple pieces of software that you can use. The first one, and I had some of you download, it's called 123D Catch. It is free for the iPhone, for the iPad, and for Android. It is part of AutoCAD's suite of stuff. If you have not looked at AutoCAD stuff, they give away a ton of software. ThinkCAD is probably the easiest 3D modeling software that I've seen for kids. ThinkCAD 123. ThinkCAD 123. Oh, Tinkercad. Tinkercad. Yeah.
So it was 123 catch with a K or catch
C.
with a C?
123D catch with a C. But before we dive into that one, I wanted to show you some of the other ways of doing it. The best software that I've found so far is Memento. And it's free, and it's relatively new. I've updated this since the last time I've given the talk. Some of the other software is more difficult to configure and get up and working, but Memento is pretty nice, and I'm going to jump over to that. Here it is. So you can see this is a rock. Just a rock, I know. Not very impressive. But it's a 3D rock. And you see all these little triangles? This represents all of the camera shots that were taken for that. So the computer has to take all of those images. Now I think they limit you in the free version to 70 images. But you take a whole bunch of pictures. All the way around the rock. Like a lot of pictures. Like a whole lot of pictures. Now, unfortunately, like I said, the free version limits you to like 70 pictures. So this is done with just 70 pictures. But I took a whole bunch of pictures and I let the software pick the pictures it wanted. And it went through and just picked pictures that it wanted to use. I figured it probably knows better than I did. So it just grabbed some pictures, and then I pressed the button, and I'm not going to do it now because it takes a long time. But I was able to turn off my computer and drive home. Because what it does is it uses a cloud server. It'll take the photos, and once it uploads the photos to the cloud server, it will do all of that on their end. So in terms of 3D scanning, the biggest hurdle, the biggest thing to get past is the processing power of the computer and the time needed. I used another piece of software to do this. It's called Visual SFM. Unless you're really into tech and computers, I wouldn't even go there. It took probably